magnitude with proper units and particular direction are called vector quantities. Examples: velocity, weight, force, torque, displacement, acceleration, etc. Unit vector. A vector whose magnitude is 1 is called unit vector. It is generally used to indicate the direction of vector. A unit vector in a given direction is represented by any alphabetical letter with a cap upon it, e.g. Consider a vectora. Its unit vector A will be A equals A. Null vector or zero vector, it is a vector of zero magnitude and arbitrary direction. E.g. the sum of a vector and its negative vector is a null vector. A plus minus A equals O. Equal vector or zero vector, two or more vectors are said to be equal if they have same magnitude and direction. Vectors A and B are equal vectors because they have same magnitude and direction. A, B. Negative of a vector. A vector having the same magnitude but opposite in direction to the original vector is called negative of a vector, e.g. Consider a vector A is represented by straight line. The negative of a vector is represented by minus A, as shown in figure. A minus A. Multiplication of a vector by a scalar. When a vector A is multiplied by a number n greater than 0, then a new vector NA is obtained having the same direction as that of A, but a magnitude n times the magnitude of A, i.e. NA equals NAA. When n is the positive number, the direction of the vector is not changed, but it is reversed when n is negative. 2A minus 2A. Rectangular components of a vector. It is possible to split up any vector into two or more parts. These are known as components. If the components of the vector are mutually perpendicular to each other, then these are called rectangular components. Physics by Bilal Zia. Physics ECAT and MDCAT. 20 PAGE. Compiled by Enger M. Bilal Zia. Explanation. Let a vector A represented by op. Making an angle theta with the x-axis. In a plane, a vector has two rectangular components. One may be x components along x-axis and the other y component along y-axis. To find value of these components, draw the given vector A in xy plane such that its tail lies at origins. From the head of vector A perpendicular is drawn on x-axis. The length of this perpendicular is value of y component of vector A and denoted by A1. The length of line between foot of perpendicular and the origin is the vector of x component of vector A. It is denoted by ax, or ax equals a cos theta. I equals a sin theta. Determination of magnitude of the resultant vector A equals square root ax2 plus I2. This is the formula for magnitude of a vector in terms of its rectangular components. Determination of direction of resultant vector theta equals tan 1 I ax for any number of coplanar vectors A, B, C. We can write r equals square root ax plus bx plus cx, 2 plus I plus by plus psi, 2 and theta equals tan 1 I plus by plus psi, ax plus bx plus cx, theta equals tan 1 rhi rx. The exact value of theta can calculated by the help of rectangular components. The sign of rx and rhi determine the quadrant in which the resultant vector lies. Irrespective of the sign of rx and rhi determine the value of tan 1 rhi rx equals phi. Knowing the value of phi, angle theta is determined. If both rx and rhi components are positive, then the resultant lies in the first quadrant and the direction is theta equals phi. B. If rx is negative and ry component is positive, the resultant lies in the second quadrant and its direction is theta equals 180 degrees phi. Physics by Bilal Zia. Physics, ECAT and MDCAT. 21 PAGE. Compiled by Enger M. Bilal Zia. C. If both rx and rhi components are negative, the resultant lies in the third quadrant and its direction is theta equals 180 degrees plus phi. if Rx is positive, Y is negative, the resultant lies in the fourth quadrant and its direction is theta equals 360 degrees phi. Scalar product OR dot product. When a product of two vectors results in a scalar quantity, such type of product is called scalar product or dot product of two vectors. Consider two vectors A and B, and theta is the angle between them. Their scalar product is defined as A. B equals AB cos theta. Where A and B are magnitudes of vector A and B. Explanation. As we know, A. B equals AB cos theta. Consider two vectors A and B as shown in Fig. A. Draw a perpendicular from head of vector B on vector A, then the RHS of the equation I can be stated as A. B equals A B cos theta A. B equals A projection of B on A. B equals A component of B on the direction of A. Similarly, from Fig. B. A equals B A cos theta B. A equals B projection of A on B. A equals B component of A on the direction of B. Characteristic of scalar product. The scalar product is commutative, i.e. A. B equals B. A2. The scalar product of two mutually perpendicular vectors is 0, i.e. A. B equals AB cos 90 degrees equals 0, 3. The scalar product of two parallel vectors is equal to the product of magnitudes. Thus, for parallel vectors, theta equals 0 degrees, i.e. A. B equals AB cos 0 degrees equals AB, and for anti-parallel vectors, theta equals 180 degrees, i.e. A. B equals AB cos 180 degrees equals ABIB. The self-product of a vector A is equal to square of its magnitude A. A equals A cos 0 degrees equals A2B. Scalar product of two vectors A and B in terms of their rectangular component is written as A. B equals AXI plus H plus ASK. BXC plus BIJ plus BZK, ORA. B equals AXBX plus IBY plus ASBZV. Scalar product obeys the distributive law, A. B plus C equals A. B plus B. C7. In the scalar product of two vectors, the product of unit vectors I, J and K is physics by Bilal Zia Physics ECAT and MD CAT. 22 PAGE. Compiled by Enger. M. Bilal Zia. I equals J. J equals K. K equals 1I. J equals J. I equals K. I equals 0 where I, J and K are unit vectors along x-axis, y-axis and z-axis respectively. Vector product OR cross product. The vector product of two vectors result into a vector quantity. The product is called vector product. The vector product of two vectors A and B is written as A times B. Thus, the vector product is also called as cross product. Let two vectors A and B are making an angle, theta, with each other, then their vector product is equal to another vector C, which is given by the relation as A times B equals C equals AB sin theta n, where AB sin theta is the magnitude of vector C, i.e. C equals AB sin theta, and n is a unit vector perpendicular to the plane containing A and B, and it shows the direction of C, which is found out by writing